Well, good morning, everyone, and welcome. I'm Basil Dewhurst, Senior ICT Project Manager here at the National Film and Sound Archive in Canberra, and I'd like to welcome you today on behalf of the AI for LAM Australia New Zealand chapter to this third Fantastic Futures 24 webinar, where John Dunn and Emily Lenimer will present on the audiovisual metadata platform and AI ML tools for metadata creation. It's really good to see so many people here. And as we've done with previous webinars, we'll be recording the session and publishing it so that others can view it after today. At this point, I'd like to hand to Sydney Shep, Associate Professor and Reader in Book History from the Victoria University of Wellington. And Sydney, perhaps you'd like to start us off with an introduction and a welcome from across the Tasman in Aotearoa, New Zealand.
Indeed. Kia koutou, na mauna, na awa, na waka, na tupuna o Aotearoa, e te whenua moimoia, e hui hui mai nei, tēnā koutou katoa. To you, the mountains, the rivers, waka, the ancestors of Aotearoa, and the land of the dreaming that are gathered here, and those of you from further afield, greetings to you all. Nau mai, haere mai, piki mai, warm Pacific greetings from Te Whanganui Atara, Wellington, New Zealand, Ko Sydney Shep taku ingoa. I'm one of the AI for LAM Australia New Zealand chapter coordinating committee members beaming in from Waitiata Press, Te Wharetau Waitiata o Te Heranawaka, Victoria University of Wellington, Wellington, New Zealand. Welcome to you all. And as Basil says, this is being recorded. So even though we had a huge number of registrants, which is wonderful, I think we're up over 190. Those of you who have decided to join us today in live time, welcome. And if you want to do a bit of self-study after the fact, the recording will be made available on our YouTube channel in due course. Over to you, Basil.
Great, thanks, Sydney. I think we're probably waiting on coffee lines here in Southern Australia. There may be some delays, but certainly the number of people is growing as we speak. So I personally, I'm coming to you today from Ngunnawal country, on which Canberra is located. And I was reminded recently of the rich heritage of this spectacular country while walking at Tidbinbilla, which is in the foothills of the Brindabella Mountains to the west of the city. Part of Tidbinbilla is a Ngunnawal men's initiation area that is a place really where boys become men. And while walking there, I was reflecting on how important that place is for the telling of stories and the passing on of traditions and knowledge, and has been for countless years. It's quite an amazing place. So today I'd just like to acknowledge the traditional custodians of this land and their stories, their living heritage, and their elders past, present, and emerging. And we'll be using the chat function a bit today. So I'd invite you at this point to introduce yourselves and perhaps state the name of the traditional lands that you're joining us from, as a way of showing the diversity of the places that we come from. You might also tell the group why you're interested in this topic today, if you can, and please log any questions you have for our speakers in the chat, and we'll get through as many as we can at the end of the session. We've also got a couple of chat helpers in the session today, Ingrid and Ashlyn, who'll be watching out and can answer any incidental questions that we have. We'll be aiming for a presentation of about 30 or 40 minutes, followed by questions of around 15 minutes. And just by way of our introduction, our speakers today are John Dunn and Emily Lenimer. John is Assistant Dean for Library Technologies at the Indiana University in the USA, and he oversees information technology development and operation for the IU libraries. He served as principal investigator for the audiovisual metadata platform project that we'll discuss today, and currently co-chairs the IIIF Audiovisual Community Group. Emily is the head of digital media software development, and her team develops systems that support access to digitized AV materials, including the large volume of content digitized by the university's Media Digitization and Preservation Initiative. Both John and Emily manage the digital repository and access systems for audio and moving image collections at the university. And in this webinar, we'll be discussing the Mellon-funded audiovisual metadata platform project, which is exploring the integration of artificial intelligence, machine learning-based tools into workflows for the creation of metadata for audio and moving image collections. So without further ado, take it away, John and Emily.
Okay, I'll go ahead and share my screen.
Great.
Let's see if we can get that working. Okay, how's it look for everybody?
That's great.
Excellent.
Great. So thanks, Emily. And thank you for inviting us to join you this evening for us to talk about our work on the AMP project and looking at use of AI in workflows to help describe audiovisual collections. My name's John Dunn, and I am joining you from Bloomington, Indiana. And I'd like to acknowledge and honor the Miami, Delaware, Potawatomi, and Shawnee people on whose ancestral homelands and resources Indiana University Bloomington is built. So next slide. So just a little bit of context before we jump into talking about the project. For those not familiar with Indiana University, as you might not be, we're a very large Midwestern public university in the United States that focused on both research and teaching. We have 7 campuses in the state of Indiana. Emily and I both work for the Indiana University Bloomington libraries, and on the Bloomington campus, which is our main residential and research campus, we have a very large number of special and archival collections really spread across campus, both within the libraries, but also in many collections beyond the libraries. And this is, think about 15 years out of date, but there was a survey that identified over 3 million special and archival collections items across the Bloomington campus. And as part of that, we have a significant number, as we'll get into, of audiovisual resources, and quite a long history of work on the use of digital technology with these collections for both preservation and access, starting back in the 1990s with Variations, which is early kind of web-based music library system for audio and later musical scores. Back in the 2000s, we worked with partnered with a number of other institutions, including the University of Michigan and Harvard University, on projects looking at preservation and access of ethnomusicological research collections, video collections, as well as best practices for digitization as a means of audio preservation. And then in the 2010s and beyond, we have developed and supported Avalon Media System, which is an open source repository system for to support access to audiovisual collections. Next slide. So in the context of all of that, back in around 2015, we launched a project called the Media Digitization and Preservation Initiative, or MDPI. And this was really recognizing the fact that we had these significant audio, video, and film collections that were becoming endangered, in particular audio and video collections, through a combination of format degradation and format obsolescence, and that within a wide range of audio and video formats, we had significant collections and significant kind of cultural heritage that risked being lost. And so we started a project that was really funded and initiated by our then university president, Michael McRobbie, who actually used to be at the ANU in Canberra before he came to Indiana. But the effort to try to digitize, for purposes of preservation primarily, but also access, to digitize all of the rare and unique audio and video recordings across our campuses, as well as a significant portion of our motion picture film holdings. Next slide. So over the course of the subsequent 6 or 7 years, we digitized over 200,000 audio recordings, close to 100,000 video recordings, tens of thousands of reels of motion picture film, representing dozens of formats, including magnetic formats, groove formats, and a variety from a variety of eras of audiovisual media history. These collections came from over 70 different departments and units across the university and represented diverse genres of content, including ethnographic content, instructional films, music performance, oral histories, and many other types of content, ultimately producing about 20 petabytes of audiovisual data to be produced. And if you're interested in finding out more about MDPI in particular in that effort, mdpi.iu.edu, you'll find more about that. But the problem we had with all of this is, well, so in many cases, we were digitizing things that we didn't actually know what they were. Because of the kind of format obsolescence issues around audiovisual media, many collections and collection managers had materials that they actually couldn't really work with or provide access to in their collections until they were digitized. And so we really took a mass digitization and sort of digitized first approach to rescuing these collections and producing the large amount of data I just mentioned. But because of the distributed nature of these collections, the fact they were managed by many different units using many different staffing levels, approaches to description or lack of approach to description, we had a very wide range of metadata. So we had, this is an example of a VHS video recording from our music school of an opera production of Rake's Progress by Stravinsky. And you can see on the right, there's pretty detailed metadata in terms of what this is, when it was recorded, who was involved. Emily, if you can go to the next slide. Performers, when this was recorded, et cetera, et cetera. So pretty detailed metadata. To contrast that, on the next slide, this is an example of perhaps what is more common across the MDPI collections, which is that the only metadata that was recorded was essentially the label that was on the videotape. I think this is another VHS recording from our university archives, and the only metadata was tape B contains digital tapes 7 through 11, which is not particularly helpful. There is an identifier in some cases that may tie back to additional paper documentation in a collection, but not a lot of readily available metadata. But as a human, I can look at this and actually start to see things like there's a date that's burnt into the video image and a time. I can kind of make out that in the background of this video of the image of the still that it says University of Indianapolis, so I know where this is. I can make out that this is our former senator, Richard Lugar, most likely, in terms of recognizing the face. But none of this is readily available as metadata for someone to find and discover this video in the collection. And so we started to look at how we could potentially deal with this issue beyond massively staffing up to try to describe all of this content. And in partnership with AVP, which is a consulting firm that works a lot with digital asset management and has a history in the audiovisual archiving world, and ultimately other partners at New York Public Library and University of Texas at Austin, we came up with this concept of AMP, the Audio Visual Metadata Platform. And the idea was that looking out there, that the tools that were becoming available, the machine learning models, et cetera, that were becoming available, could we look at how we could leverage these not on their own, but combined with human expertise to help us with this metadata problem. And AMP was really conceived of as an open source platform to help with metadata creation for these collections that could let a collection manager ultimately design and execute workflows that combine both automated, perhaps AI-based steps together with human steps for validation, verification, supplying additional metadata that only a human cataloger might be able to provide, and combine these steps into workflows that are appropriate to particular collections. So the workflow you might need for a music performance collection is quite different than the workflow you might need for an oral history collection and the tools you would need. We call these individual tools that get strung together in workflows, we call them MGMs, or metadata generation mechanisms. And so they might be an automated step, they might be a manual human involved step. If they're automated, they might run locally on a server, they might run in our or another institution's high performance computing environment, they might be a commercial cloud service. And ultimately the goal was to be able to to have workflows that could deliver metadata into different target systems, such as library catalogs, online AV access systems, such as Avalon, which I mentioned, or Aviary, which is another tool that is actually from AVP that's used by some institutions. And we wanted to build something that was not just meeting this need. We had this need at IU, but we wanted to build something as open source that ultimately could be used beyond IU. And so Emily's going to, in her demonstration, is going to show a bit how this works, but this is just a list of the particular metadata generation mechanisms that we have implemented so far. And one thing we tried to do is to have, where possible, an open source and commercial option in each category. So with speech to text, for example, we started initially with Caldi as an open source option and AWS Transcribe as a commercial option. Recognizing that there are cases where people might not want to use commercial options, where open source actually could work better. And part of our process was actually evaluating different tools in each of these categories, which Emily will also get to in a little more detail. So I won't go through this whole list, but you can, we can also provide a link to these slides that you can reference this in the future.
Thanks,
So I'm
John.
gonna
So
turn
yeah,
things
you
over to
want
Emily.
ready? Yeah.
Yep.
So I'll take over. So we're gonna go ahead and try and do a live demo here. So can everybody see the audiovisual metadata platform homepage?
Yep.
I'm going to take that as a yes. Okay, so we'll, this is just our homepage with a little bit of information about the project, and go in and look at a content item. Let's just pick something from the Clio Awards here. So we have the idea of units and collections for organizing resources and providing permissions. So we just have a couple of items in this collection here. We don't have a lot of metadata in AMP because it's not really intended to be a descriptive system, but a place to hold these items and to perform machine learning tools or apply MGMs to them. So we have we have a name and some description, where it lives within AMP, can refer out to an external source system. And then a content file here, there might be multiple content files. This one only has one. And this is a collection from our moving image archive. So you can play the media item here. And then you can also see the workflows, the outputs from the workflows this particular media item has been run through. So we've generated some transcripts. We've got some WebVTT. Looks like this is mostly just WebVTT. So transcript, been running it through a number of different workflows that generate transcripts for testing purposes. So that's kind of what an item looks like in AMP. The thing that's really at the heart of AMP is, is creating workflows that do what you need them to do for your collection. So putting these MGMs together in a way that makes sense for your collection. So we have a number of them that have already been created here, but I'll just go in and create a new one for the purposes of this demo. And to make it interesting, we'll do a couple of different things. So we'll create a transcript, a speech to text transcript, and also do some shot detection on this video. So I'm just going to give it a name. This workflow editor we're pulling in from the Galaxy project, which is an open source project developed out of the scientific community, built for doing scientific data analysis. And so it includes a portion of that is being able to create workflows to run your data sets through. So we're repurposing that open source tool here to provide an interface for creating workflows. So this is really easy to do, especially if you know how to put the pieces together. So here's my input. It's going to be, this one's going to be a video file. I'm going to run through it. I want to do speech to text, so I'm going to extract the audio out of it. And then I'm going to come over here and see the speech to text MGMs. So these are some different categories of MGMs that we have in AMP. So I'm going to pick speech to text, and I'll use Whisper speech to text for this one. And I can just connect these like this. It's really easy to do. These are different outputs that the MGM can provide. I'm mostly just interested in the VTT subtitles, so I'll put that there. And then let's see. So we also said we wanted to do some shot detection. So if I come down here and detect the transitions between different shots, I'll put in PyScene Detect. This is another open source tool. And the input video can also go there. And then my output, maybe I want something different than like a CSV that lists the timestamps for when shots change. So I can go ahead and request that this be formatted into the output of a contact sheet PNG. So basically an image that shows the frames where shots, it's detecting a transition in shots. And I'm going to put the video here, and then it's calling for my shots here. I don't need these frame statistics. And that's really all I needed to do to create a workflow. It's going to give me two different outputs. It's going to give me this PNG. It's going to give me a VTT file. So I'll save it, and then I'll publish it. Oops, gotta click on this little guy. So that it's actually available to run as a workflow in the system. And I'm done with making a workflow. So now I want to run it. We called it transcript and shot detection. I'll just search for a video. I know we have, whoops, I can type. It's called Body and Soul. This is a TV program of the 1960s, maybe. So I select that one, it matched, and I'm going to run this workflow. I could run workflows on whole large sets of items, hundreds of items if I want. I can also create sets of items and sort of save them as a bundle if I wanted to have a collection that I was experimenting with and I wanted to run it through different workflows or the same workflow with tweaks in it repeatedly. And then we come to the dashboard, which is kind of like where you can see everything that has happened in AMP. So all the workflows that we've run, we've got lots of stuff here already right now. There's lots of ways to filter this because you have lots of outputs from workflows. So in this example, I might filter it by a workflow. So I just created this workflow, right, that was called, oh, we don't have any results yet, so I can't do that one. Let's see this, let's say I wanted this workflow called contact sheets. So if I do that, I'll see only files, only the outputs of files that have been run through this specific workflow. Let's see, and then I can also search for individual items. So let's see, I want to see any results for this item that I just submitted to a workflow called Body and Soul. I can select that too, so you can see the item is, it's all one item. Well, it looks like you can see actually here the workflow that is in progress right now. So this is the workflow that I started. It's running Whisper. That will not be done in time to show you outputs for this demo. We do have Whisper that runs on our local HPC. We have developed an MGM that will do that directly, but it's in our test environment, not deployed here yet. So this is just running on the basic CPU of a VM that we're using from campus. So it's not super fast. I don't know how long the contact sheets will take. They might take a little while. But I can show you some examples from prior history for this particular item. Yeah, let me search for this item again. Bring it back up so I don't get distracted by all the different results. There we are. Okay. We're going to ignore those errors because we're in the midst of transitioning our Azure service. Okay, so here's an example of contact sheets. So we mentioned when I created the workflow that it would create contact sheets. So you can see here, this is an example PNG that's all the registered transitions that the Piscine detected in the video. And this is something that has certainly been of interest to our collection managers. And then I can also show, this one doesn't have any transcripts that have completed for it yet. But I can find something that generated a transcript. Let's see, sure, an AWS transcript. That is not what I was looking for. Okay. That is not the right step. This is what I want. Here we go. Let's find a VTT. Here's actually, this is the first video that I was showing content. Now here's an example of VTT that has been generated for this one. This came from, this was a workflow I ran that produced a VTT from both AWS Transcribe and Whisper. So this can be easily downloaded from AMP. There was one other thing that I wanted to show. So we have this section called MGM evaluation. This module was developed with the idea that it's not always obvious which MGM might be most appropriate for a collection that a collection manager or collection owner may be working with. The efficacy and accuracy of MGMs does depend on the nature of the collection. And so we have some tooling here in AMP in order to be able to test that. So to be able to take a media item, run it through some MGMs, and then compare it with the output produced from a human-generated ground truth, and then take a look at that. So I can run a new test here. This is speech to text, so it's going to be looking at the accuracy of a transcript. And so the test we have here is word error rate. And I was going to look at, let me check which one I was going to take a look at. Yes. This item right here. We think we've got a couple of transcripts already generated. Yes. So we have a Whisper transcript generated, and we have an AWS Transcribe transcript generated. So I'm going to grab both of those outputs. And then I need to have some ground truth to compare them to see how accurate they are. I should already have ground truth in the system for this one. Otherwise, I would just upload the text. But this one I've already done, so we don't have to take that step. And I can submit it, and this is usually very fast. And then I can look at the test results. So here's our word error rate test. Let's just go back to that one just to make the interface simpler. Okay, so here, let's see. Here, right here, these two are the two that we just looked at. So it just created these two test runs. So it ran the AWS Transcribe transcript and the Whisper transcript against the ground truth. So I want to visualize the results from both of those. Okay, and so you can see here we have a little chart. The one thing that's missing that would be super helpful is which color is which. The one on the left is the first one, which I think was AWS Transcribe. But you can see that in the tabular data. And then it shows here useful statistics like word info processed and word error rate, which are two of the big ones. So if we look at the table here, we can see for the Whisper transcript, the word error rate was 11% and the word info processed was 84%, and AWS Transcribe, the word info processed was 76%. So Whisper performed slightly better than AWS Transcribe for this particular item. And then you can also take a look at the actual outputs, which is useful as you're sort of trying to understand, like, what types of things does the machine learning tool get wrong? Are they errors that are significant to the community or not? So you can scroll through and see what word was typed in the ground truth and what word for that, what was the equivalent thing that the MGM tried to produce. And here you can see the MGM didn't produce anything for some speech. It substituted a word here, got a bunch of words right. It substituted plate instead of play. Got a bunch of words right, a bunch of words right there in a row. Let's see, I was just looking to see if there was an insertion error, but it's lets you kind of scroll through and get a feel for what's going on in the transcript. And then the last thing was just that we do have batch ingest tool. so that you can drop a bunch of files into a Dropbox and then create CSV using this template to upload, say you wanted to upload 100 items or 1,000 items for a collection at a time to AMP. So I think that's all that I have for the demo. John, is there anything that you can think of that I should show that didn't already?
No, I think that's good. Simon had a question about which Whisper model we're using. Do you know for the default implementation? We're doing a lot of
Yeah.
exploration, of different models. But for
Yeah,
the
so let me just bring up the Whisper. So here is our Whisper MGM. So this allows you to say which model you want to use. So you have the choice of any of the models that were available when we installed this, when we added this MGM to AMP. So right now we have large V1 and V2 here. I think in our test instance where we're developing more actively, we also have V3. That's the newest large model. So you can choose to run any of them. So that's one of the configurations when you create the workflow is which model. We'll show this a little bit in the slides, but so far we're starting experimentation with that, and it can depend on your collection which model is most effective, whether it's large model or medium model. All right, so I can, let's see, run back to the slides here. I talked a little bit about this, but I just wanted to share some sort of stats that we had gained from earlier testing we did earlier in the project. So again, I shared the MGM evaluation module where the goal is to test how accurate is each MGM, and you create a ground truth for a media item where your humans, say, watches the video and records any text they see on the screen if you were to, say, be looking at accuracy of a video OCR MGM. Then you run your media item through that MGM and you compare the output, and you get things like precision. You can calculate scores like precision or recall, so how accurate were the MGM's guesses, or how much of the truth did the MGM detect, or things like word error rate or true false positives. I'm just going to share a few scores that we found. These are like by no means to say this is what MGM works best. This is just some example data that we've gathered. This is a speech-to-text example averaged across 4 different media items that we ran through AWS Transcribe and Kaldi. Kaldi is an older open source speech-to-text model. And it's very easy to see that AWS Transcribe is performing way better than Kaldi. So you can see it's processing way more of the word info correctly. It's in yellow. And Kaldi has a much higher error rate. When we were originally doing our testing, Whisper hadn't actually been released and incorporated into AMP yet. So we've since done that. So we did some testing with a different set of files between AWS Transcribe and Whisper. And so this chart shows average scores across a small collection of 3 videos, videos that contain TV ads. And you can see here that AWS Transcribe performs a little poorer than Whisper. So the yellow here, the word info processed is slightly lower than Whisper, and the error rate in AWS Transcribe is slightly higher. And also, interestingly, AWS Transcribe is performing significantly poorer than in the last chart I showed, where it had about like a 91% word info processed. So performance of both models, of really all models, varies across different collection types. And so this example, the videos that we're using are TV ads from the 1960s and the 1970s, and they have many musical jingles in them. And that type of musical jingle or singing can be more difficult for models to correctly transcribe. Much more than just speech, you or me talking. And in fact, in this instance, the Whisper medium model performed much better than the large model V3, the new Whisper large model. Just did a lot of hallucinating on these videos. Medium model was much better. So I showed this already, so I'm going to go past this. Oh, the one thing I was going to say was this gives you an example here. Some errors are meaningful. So this one here, the National Baseball League, was what it was supposed to say, was actually said in the video, and it came out as the National Army, which is that's not a great error to have in your transcript. But here's something like the 1920s written numerically versus the early 1920s written in text. The meaning doesn't really change there. So it's important to note that not every error is meaningful, and that can vary by transcript. So, and then I was just going to show from a couple of other MGMs. This is shot detection, so that's one of the ones we did in our sample workflow. And we have the Azure Video Indexer as our commercial tool and PyScene Detect as our open source, and they're both performing fairly similar here. You can see the numbers are similar. And the scores show precision of over 75%, which means we're not getting tons of false hits for the shots. And recall for Azure is about 90%, which means that most shot changes are getting identified. And then you can see this in the comparison chart on the right. So there are more true positives than there are false positives or false negatives. So here's video OCR for an educational film from 1970 using our Azure Video Indexer again and Tesseract, which is an open source tool. And you can see that video OCR is like way more challenging for these tools. So on the last slide, we saw like greater than 75% precision and 90% recall. Here, the scores are much lower. In particular, the precision is pretty bad. The highest precision is like 39%. Recall is better, but this is, you see how many false positives in the chart on the right. So we have more false positives than we do true positives. So we got more wrong than we got right. So it's not very good precision. So for video OCR, some of the challenges lie in deduplication. So video provides many frames, and the MGM has to determine when does a term start and stop. And so we often see repeated words when we're doing video OCR in videos. So then the other thing I wanted to talk a little bit about was one of the last phases of our project. We worked with collection partners to evaluate whether the MGMs produced output that was useful for some specific use cases we had talked about with them that they helped identify. So like, did they feel like they could actually use these outputs? So we worked with collection partners from 4 units at IU to evaluate the usefulness of outputs, and we provided them with these scores I've been showing, and we asked whether they would actually use the MGM output the way that it was, whether it would need to have some human correction, or whether they were like, this is not useful at all for anything, to try and understand, like, are there MGMs producing data that could be put to use? And so just to share a few results from that, in terms of open source versus commercial MGMs, the only significant performance variation we saw was speech to text. So we were again using Kaldi at this time. Kaldi is not producing transcripts, speech to text transcripts that are useful at all. But they were willing to consider using AWS Transcribe for providing terms for full text search, to provide to a cataloger to render assistance to them, and maybe even in some units willing to provide transcripts that would go out to users themselves. And we did not test Whisper with our collection staff. Our shot detection MGMs could provide ways to provide a visual overview of a media item, or to help identify dead areas in our digitized items. We have a lot of dead air with our digitized collection. And I showed the contact sheets, which the collection managers were really interested in. The named entity recognition MGMs mostly were considered useful at this point for providing output for a cataloger who's maybe trying to enhance a record and understand what types of things are in this media item. And at the moment that we were doing testing, our audio segmentation and video OCR MGMs were not providing output that they were seeing particular use in at that time. So needs more refinement for what we might do with those. So we're currently still developing AMP. We have a 1.01 release that's available for download. It can be tested locally. It requires a Rocky Linux VM for installation, and there's an automated script that does the download, the installation, and the configuration. It's quite large, which is why it's not in a Docker container. And then there's a URL here that points to our organization in GitHub, and there's a README with all the relevant links. And so our grant work is completed. So now we're focusing on partnering with IU collection staff on pilot projects, working through our technical debt. So like we're just finishing a Node.js upgrade for the front end and designing workflows that support batch processing. So one of our pilot partners is the Indiana University Libraries Moving Image Archive. They have, I mentioned TV ads. They have a fairly large collection of TV ads from the 1960s to the 1990s. This collection is a significant interest to researchers and companies, but it's hard for them to support the use case of finding ads for a company or a product, or ads that contain a certain type of content. So for example, ads that contains images of rings or jewelry. So we've created a Whisper MGM that's capable of sending jobs out to the campus HPC to improve our throughput. And we're planning to use that to generate transcripts for all 2,400 items in this collection. And then we're also just beginning to take a look at vector search that uses AI transformer models to enable open-ended text query to identify videos of interest. So there's potential for AI models to be capable of taking images, so frames from a video, and translating them into a mathematical conceptual space. And if we do similar transformations on text queries, we should be able to find conceptual similarity between words and images without any descriptive text. It's not clear if this tools can actually accomplish this yet, or how we might integrate it into AMP, but it's a really interesting area of research to explore. We're also testing the use of gentle alignment provided by Caldi to see if we can improve timestamps for some transcripts that were generated for our bicentennial oral history collection that initially did not have timestamps. And then as we're working on pilot projects, we're exploring ways to integrate systems such as our primary AV discovery and access system, which is the Avalon Media System, integrate that with AMP, looking at APIs for batch and taking a look at S3 endpoints for content buckets so AMP can pull media content directly without users having to upload it. And I think that's it for me.
Thanks, Emily. So I will wrap up quickly with a little bit about lessons learned and next steps. So, some of the lessons learned working with proprietary tools, while in some cases they can perform very well, there's still, we've seen a lot of concern from some of our collection managers and others involved about kind of the black box aspects of them, the fact that you can run, AWS transcribe multiple times over time and get quite different outputs because the models are constantly being updated and changed and perhaps improved, and there's no versioning of that. Emily, if you can jump back a slide. There we go. And also the issues around lack of clarity in license terms, particularly about retention of uploaded data for possible model training and product improvement. That has become better, I think, but initially was quite unclear with some of the cloud services. But as I said, for some tests, they work well, though open source is continuing to improve, and Whisper is a good example of that. We've definitely found that these kind of off-the-shelf, out-of-the-box pre-trained models don't always do what we need to do. We have significant amounts of music content where being able to do more specific training around music tasks would be useful. Object detection is another area that we've not explored super in depth, but the kind of pre-trained, there's lots of presentations on this out in the AI for LAM world, but models that have been trained on kind of YouTube content don't recognize things in historical image content. And so we think there is a lot of potential for collaboration with research communities, with machine learning researchers who are to develop new models and new tools that we could integrate with AMP. Some technical challenges around Galaxy. Galaxy is great. It provides a nice UI for creating workflows, but it is challenging to scale to some degree and is not really designed to integrate steps that potentially have long wait times, like something that involves engagement of a human. Another challenge we've had is that we're working with a lot of librarians and archivists at Indiana University and our partners, and we've been there's been a lot of excitement from them about the potential of AMP. But what's been more challenging is to actually, archivists who have time to work on R&D projects. It's challenging for archivists to find time to work on R&D projects because they always have researcher requests they're dealing with, processing goals that they're trying to achieve. And so being able to set aside that time for R&D is challenging and something we're continuing to explore. There's also more work certainly needed on some of the ethical considerations around some of the MGMs, not just the use of commercial tools in retaining data, but potential bias in things like facial recognition. And when that is used, we've been very careful with that. with particular MGMs, such as facial recognition, for that reason. And then finally, it's been a little bit challenging sometimes for librarians and archivists to kind of visualize the utility of the results when you're used to things like EAD finding aids and MARC catalog records as your metadata that don't necessarily incorporate the ability, for example, to tie metadata to particular time ranges in video and let a researcher or a user better find particular points or segments in video because they're not used to having systems that can do that. And so finding ways to get the output of AMP more into a discovery and access platform like Avalon, I think we think would help with that. And then one more slide, I think. And where we go in the future, we're working on integrating additional MGMs and target systems such as Avalon that Emily mentioned, trying to get this more integrated at IU with our production workflows, looking for opportunities to collaborate with researchers at IU and elsewhere to connect and train new models. Very interested in how this ties into IIIF and IIIF support for AV through use of web annotations. So it's something we'd like to explore more with the IIIF community. And then really we've been funded, I should have mentioned this up front, funded very generously from the Mellon Foundation to do this work, but looking at how do we sustain the ongoing development and support for adoption of AMP at IU and beyond. And next slide. So yeah, that's it. And we have a bit of time for questions. We ran a little long, I think, but thanks again for having us, and yeah, happy to take questions.
Well, you're right, John. That is an amazing system. I can really see how it's a sort of a game changer for not only your collection managers, but also for, you know, your end users and your researchers in terms of making available the assets that you hold across your collections. Just awesome. We do have a couple of questions in the chat, which I might parrot for you. I'll start with one from Alexis. So in terms of the IT requirements to set up the type of...
I think Alexis's question's been covered by Emily already, and I think unless there's more to cover, there's a question from Rowan Payne about the work with AWS Comprehend, if you check in the chat.
Okay.
Oh yeah, maybe I could.
Yeah, Rowan, you go.
Thanks, Ingrid. Maybe I could just, because it's not really a question as I've posted in the chat. Thanks, John and Emily. That's a really fantastic project. I guess we have experimented with AWS Comprehend, and John has sort of covered some of our concerns with it around the licensing and some of the nervousness that we've had around using that and other commercial models where, yeah, exactly as you were saying, we're hesitant where the license terms basically say we're going to take your data, we're going to train it on this model, and we have no idea what other training, what other data is inputted into those models. Is there, I guess the question is how are you working that through the institution, that type of issue, and is there any sort of policy being looked at there?
Yeah, it's an interesting question. So we're both having those discussions within the institution and then with, in some cases, these commercial partners. So I've had a number of conversations with AWS about these.
Right.
And one thing about AWS, for example, is that the policies around the individual tools vary. So for example, AWS Transcribe, the default is that customer data, supplied data can be retained for training purposes. And you have to specifically opt out of that. Whereas I believe with Comprehend, and I may be wrong about this, some of the other services, it's the opposite. And so we've had a number of conversations about that kind of lack of clarity and inconsistency. Within the institution, we are developing policies around kind of use of AI services and generally the challenge, I guess, is that a lot of these tools are part of larger cloud services platforms, right? Like AWS or Microsoft Azure or Google Cloud Platform or IBM Watson that get used for a lot of things, and the contractual language, the privacy policies, other kind of documentation around what they can and can't do with customer data is not written specifically about the AI services, and so it can be a bit hard to interpret. And
Sure.
that's a conversation that we've had with our IT security office and policy office about kind of how we can clarify that more with the vendors. So yes, we have not solved this problem. So for example, Microsoft will absolutely assure us that our contract language says that they will not and cannot retain data that we upload for ongoing training purposes. However, that's not immediately obvious from the actual language in the contract.
Right. Great. Yeah, no, it's yeah, I guess it's an emerging area for all of us. It'll be good to yeah, keep in touch around the developments for that. Yeah, thank you.
Thanks, Rowan. John and Emily, I've got a question from Shane Appleby. Have your sample data sets been mainly English, or are you using results from, based on multiple accents or languages?
Emily, do you want to take that one?
Do you want me to take that one? We've mostly been testing in English right now. So obviously the majority of our collection is in English. And also that is where many tools, as you probably know, perform best or have received the most training content is in English language. Obviously, Whisper provides support for many languages. We do have materials that are non-English, especially in our ethnographic music collections. However, those materials do present some fairly significant other kinds of challenges in the types of materials. So there's lots of music, there's sort of not a lot of well-recorded speaking, good quality audio in those collections. They're much more challenging. So they've not been a first focus of our testing just because the nature of those collections is more challenging. There certainly are people out there who are working with Whisper and interested in Whisper for low resource languages. We have not done anything specific thinking about like accents. Again, like because the majority of our collection doesn't necessarily fall into that area.
Fantastic. Thanks, Emily. We've got a question from Maddie B relating to the AMP stack. Is the stack AMP extracting this from the preservation original or a smaller derivative file? And secondly, are you using a demilitarized zone, I guess, to access the files to protect them from your enterprise systems?
Well, I can answer the first part,
Sorry,
which is we've been using the high quality access derivative. We're not using the archival version of the file, although you can use any derivative. You could use the archival version. AMP is not. It will just take whatever you give it in terms of the media files. So when we've been testing, we've primarily been using our high quality derivative. We generate several levels of quality. I'm not sure about the DMZ part of that question. I don't know if I understand that.
Yes, I'm running on a small amount of text myself. But I suppose, yeah.
I mean, this is all running. So for us at IU, it's running within our enterprise and research computing environments that are hosted within the university data center that have certain security practices around them. And we have, for our testing purposes, have certainly not worked with our most sensitive collections in terms of privacy concerns, in terms of representing indigenous cultures or other things like that. We have worked with content that may present copyright concerns in some cases, but is not does not carry other risks with it. I think if we got into some more sensitive collections, we would need to be, you know, much more concerned about information security.
Yeah, for sure. So in terms of your work, then you were talking about how you you take ethical concerns or legal concerns into account. Are you working with an overarching, I guess, responsible use of AI framework or set of principles, or is that something that you're navigating as you hit particular issues?
I think it's something that we have not, I think it's something that we will need to define for perhaps both AMP and Indiana University, but it's an evolving conversation. We sort of started this work before most institutions had developed such sets of principles for themselves. So certainly we've been following, you know, the work on responsible AI and ethical AI and so on, but we've kind of dealt with it more situationally, I guess, and pragmatically so far. But I believe we do need to step back as an institution at some point and be a little bit more methodical.
Fantastic, thanks, John. So we've got a question from Sotiros Alpanis at the State Library of New South Wales. They're wondering if there was any appetite to run material against several models and to use a composite score in the output. Apparently the Tiger project at SL New South Wales did something similar.
Sorry, I'm Googling it because I don't know anything about that project. And I'm like, I'd be interested in learning more. I am not sure what you mean by a composite score in the output.
Maybe we could.
I assume this is.
I could explain
go
a
ahead.
bit if that's useful.
Yeah.
I'm actually at the library, State Library of Victoria, not New South Wales, but I'm an admirer of the Tiger project.
My mistake.
Yeah, no problem. They did something similar to what you're doing, but with visual material, and they ran the visual material against several different AI machine learning models, and instead of you know, outputting just scores from one of the models, they cherry picked, you know, the most confident scores from each one. So I was wondering if that, you know, that could be a similar approach which might work nicely with the way that AMP works.
Yeah, so I don't recall that we have talked about that unless it was before my tenure, but that is a very interesting suggestion. John, did you guys look at that earlier in the project?
We have not actually done that. We had talked about it, and it's, you know, it's very similar to what we did, you know, what libraries did 20, 25 years ago with OCR, right? We buy these OCR systems that had 5 different engines in them, and, you know, essentially do voting on the OCR results. So it's a very similar approach to that. It would be fascinating to explore.
We do have confidence scores, you know, from most speech to text models, and other models do provide confidence scores that you could use to do that sort of cherry picking.
That's fantastic. Well, unfortunately, noting time, I think we might wrap at this point. John and Emily, thank you very much for your presentation today. It's an amazing system and certainly has legs. It's just, I'm blown away. What a platform to provide to your users. For those who've attended, there's a number of links that have been posted in the chat. Encourage you to have a look at those for further information. I'd also like to thank Sarah, Sydney, Ingrid, and Ashlyn for helping today with the chat and with organisation. Obviously, AI for LAMP provides the community with a lot of you know, resources and support for events like this. So definitely encourage you to have a look at AI for LAMP resources on the web. And if you're keen, you're welcome to join our Slack channel. We, as a final plug, we're promoting the Fantastic Futures 2024 conference, which is happening here in Canberra in October at the National Film and Sound Archive, and we'll be having some pretty exciting satellite events. So have a look at via Google, because I don't have the link with me. Have a look at our conference homepage for emerging information, and please register if you can make it. It is going to be an awesome conference. I'm really looking forward to it. And lastly, if you have projects that you'd like to showcase or present for feedback, or topics that you'd like to see in future discussions, please let us know. Yeah, so on behalf of us here at the NFSA, thank you very much. And thanks again, John and Emily. Much appreciated.
Thank you for having us.
Thank you so much.